Hello everyone, my name is Rajesh. My friend name is Murli Karthik. We are studying in Mohan Babu University. We recently done an online internship on embedded systems at EMERTXE Information Technologies Private Limited. In that, we done a project which is simulation of washing machine using PIC family microcontroller. This is the presentation to show you that what we have learned from the internship and the project demo. Let's see table of contents. Introduction, embedded C. In embedded C, we have keywords, data types, conditional statements, arrays, macros, operators, and microcontroller. In microcontrollers, we have timers, interrupts, pins, and block diagram of microcontroller. Software requirements, MPLAB, XE8 compiler, PICSIMLAB. Hardware components, CLCD, buzzer, fan, switches. What we have learned from this internship. From this internship, we learned basics of C, introduction of embedded systems, and embedded C program using switches, buzzer, CLCD, timer using MPLAB, and finally, this internship has proved my embedded C language knowledge. Modern day washing machines are mostly used in every home appliances. Modern washing machines are increasingly integrated with advanced embedded systems, transforming them into smart, energy efficient appliances. These embedded systems consist of microcontrollers and sensors that enable precise control over wash cycles, water temperature, spin speed, and detergent usage based on the load and fabric type. Features such as load sensing, fuzzy logic, and IoT connectivity allow users to operate and monitor the machine remotely via smartphones, while ensuring optimal performance and minimal resource consumption. By leveraging real-time data processing and adaptive algorithms, embedded systems make modern washing machines more reliable, using friendly and environmental conscious. What is an embedded system? Embedded system is a combination of hardware and software using for to operate specific tasks. An embedded system is a specialized computer system designed to perform dedicated functions or tasks within a larger mechanical or electrical system. Unlike general purpose computers, embedded systems are typically built into devices and operate with limited hardware and software resources. They consist of a microcontroller or microprocessor, memory, input or output interfaces, and often real-time software to control specific operations. Found in applications ranging from household appliances and automobiles to medical devices and industrial machines, embedded systems are essential for enabling automation, precision, and intelligent behavior in modern electronic products. Embedded system components. All components are integrated in a small chip, which is the microprocessor uh, connecting with connecting through buses like data bus and address buses. In these components, we are more preferably used RAM, ROM, Flash, FPGAs, Ethernet, USB, CAN, DAC, ADC, crystal oscillator, audio amplifier, sensors, power supply, user interface, display. What is embedded C? Embedded C refers to the standardized set of extensions to the C language. It is the uh, extension of C language which is updated version of C. It is mostly used in embedded systems. Embedded C incorporates hardware-specific pragmats and requires cross-compilation to firmware formats, ensuring efficient, real-time, and low-level hardware control suited to resource-constrained environments. Keywords in C language. There are 32 keywords in C language. We have auto, break, case, char, char means character, continue, do, default, constant, double, else, enum, extend, for, if, go to, float, int, long, register, return, unsigned, static, size of, short, struct, switch, type def, union, void, while, volatile, unsigned. These are the 32 keywords in C language. In this mostly we use break, character, int, for, etc. We use mostly operators. Operators are play a key role in any uh, language. Example: arithmetic, relational, logical, bitwise, increment and decrement, assignment operator. Arithmetical operations can do addition, subtraction, multiplication, modulus, division, etc. Relational means uh, greater than, less than, greater than or equal to, less than or equal to, equal to. Logical. Well, in logical operators, we have and, or, not equal. Bitwise is and, equal to, not, etc. Increment means increased one value. Decrement means decreased one value. Assignment operator means it assign a value to this variable. Data types. We have mostly three types of data types in C language. First, primary. In primary data type, we have mostly five data types. It is classified into five types. One is void, int, character, double, float. Int means integer. Integer values we have one, two, three, like character. Character means uh, non-variables are characters. Double and float means decimal values. And derived data types. Derived data types are classified into three types: array, references, pointers. And lastly, user defined data types. In this, user defined data types are classified into three types: structure, union, enumeration. And next will be my friend continue.
Hello everyone, I am Murli Karthik, a student at Mohan Babu University. I am also recently done an internship at EMERTXE Private Technologies Limited. We have done a project on washing machine. So from here onwards, I will continue the presentation. In this project, we used PIC16F877A microcontroller, which is reliable, low cost, and easily available. The main features of this microcontroller include it has 8-bit RISC CPU architecture with 20 MHz cycle, 4 KB flash ROM memory, multiple serial interfaces. We know that in embedded system, the main application and the main uh, concepts in that is the protocols. In this big microcontroller, it possesses USART, SPA, I2C, like these main protocols. So we use these big family microcontroller in our internship. As we see that this is the pin diagram of PIC16F877A. It is a big package, which means the both sides has pins for that, and it has 40 pins, ranging from 1 to 40. Interrupt. Interrupts are one of the most powerful features of PIC microcontrollers. Interrupts make it possible to create applications that can respond basically an event that requires a microcontroller to stop normal program execution and then jump to execute a program code related to the event causing the interrupt. Interrupts are generally classified into two types: maskable and non-maskable. Maskable interrupts are that they can be executed uh, mainly. Non-maskables are that they can be avoidable. In this any embedded system, in this embedded system or any embedded system, interrupts play a key role. Timer. Timer is a mechanism to generate a timeout event occurrence. This may occur when a pre-specified time interval has expired. Timers are defined as properties of test components. A timeout indicates the timer expiration. A timeout can be stopped, the expiration time of a running timer and its current status. Example, they may be active or inactive, can be checked. Objective. The main objective of the project we have done at MXC Technologies is we can build a robust washing machine controller on a PICSIMLAB 877A by integrating a 16 into 4 character LCD display for real-time cycle status, tactile switches for mode selection and start or pause functions, a buzzer for end of cycle and error alerts, and a temperature control fan for ventilation or cooling. But in here, we use the fan for the representation for the drum of a washing machine. The microsystem reads switch inputs on port D or port B displays current mode and progress on the CLCD. Here there is a mistake is there. If we use 16 into 4 LCD display, I am sorry for that. I will change it. It is 16 into 4 display, not 16 into 2. Requirements. The requirements for this whole project are that microcontroller, we use PIC16F877A, the core controller for managing logic, timers, sensor input, and motor control. Second, the hardware components. We use both input device and output devices. The main input devices we use are push button switches. The push button switches are also called tactile switches. For user input, start, stop, program, select. For these functions, we use push button switches. Keypad. For setting wash time, speed, or water level, we use digital keypad. Output devices, LCD. We use CLCD 16 into 4 and buzzer LEDs. Software requirements. We use embedded C code. For programming, we used MPLAB X IDE and X8 compiler, which are open source free tools. So we use the timer functions to control washing cycles like wash, rinse, spin, the time for the specific wash. So we use timer functions. State machine logic for operation flow control. Start, wash, rinse, spin, again stop. So like that, we use state machine logic. Software suite. Now we will briefly see the about the softwares we use. MPLAB X IDE. MPLAB X IDE is Microchip's free cross-platform integrated development environment for creating, building, and debugging embedded applications on PIC, DSPIC, AVR, SAM, and PIC32 microcontrollers and digital signal controllers. XC8 compiler. The MPLAB XC8 compiler is Microchip's official C compiler designed for 8-bit microcontrollers including PIC10, PIC12, 16, 18, and AVR devices. It takes your standard C code and compiles it into optimized machine instructions tailored for these microcontrollers. PICSIMLAB. PICSIMLAB is also called Programmable IC Simulator Laboratory. It is a real-time hardware emulator designed to work alongside tools like MPLAB X, Arduino IDE, or VS Code or Platform IO. It emulates microcontrollers from PIC and AVR, enables you to run, debug, and visualize embedded projects as if hardware were connected. Now we will see the peripherals which we have used in the project. The main peripheral we used is CLCD. It's a display to display the specific functions or anything in the project. A CLCD is a simple alphanumeric display, most commonly a 16 into 2 or 20 into 4 module or 16 into 4, driven by controllers like that Hitachi HD44780. These modules communicate over a 14 to 16 pin interface using pins for power, contrast, control signals, and data lines. Although 4-bit mode uses only D4 to D7. In most PIC16F877A projects, it's wired in 4-bit mode to conserve I/O ports with two control lines, which are RS and E, and 4 data lines, allowing efficient display of wash cycle modes, timers, status, messages, and error alerts. The next main and primary peripheral we use it is switch. Switch, a tactile switch. Here we use a tactile switch or push button switch. So let's see what is a tactile switch. A tactile switch is a small momentary push button used in electronic circuits to complete a connection only while it's being pressed. It provides a distinct physical bump and often a soft click when activated, giving users tactile and auditory feedback that their input was registered. These switches are highly durable, reliable for frequent use, and available in various types: through hole or surface mount, sealed or low profile. Next peripheral is digital keypad. A digital keypad in PIC16F877 microcontroller is a matrix style input device, typically arranged in a 4 into 4 or 4 cross 3 grid, used to enter numeric or character data. It consists of rows and columns of switches, where each key pressed connects a specific row to a specific column. By using this array style design, we used a digital keypad in this project. The next peripheral is fan. In PIC16F877 microcontroller, a a fan typically refers to an electrical cooling fan controlled by the microcontroller as part of an automation or temperature regulation system. But in here, we used fan to symbolically represent the drum of a washing machine. So we're using only the microcontroller to display the washing machine functions. So a drum is not available in there. So we used a fan to represent that. And along with this, we used buzzer also to show us when the program is when the washing program is completed. A buzzer is uh, come to tell us the program is completed. Now I will show the project demo. This is the code for that. Now we will build this project. Build was successful, and opening PICSIMLAB, load hex file, loading hex file. So this is the first display. So we have to press key 5 to power on washing machine. So this is key 1, 2, 3, 4, 5, 6. So I'm pressing 5. So washing machine is powering on. So there are 12 different modes in the washing machine program. We have to select our required project. I'm selecting my required option by clicking once this for the switch. I'm selecting whites. To select that whites, we have to hold that switch for a while. So in that whites also, we have 4 different options from auto to max. So we have to select our required option from that. I'm selecting medium and selecting this by holding the switch. So we have to start the program by now. As we see, I have selected the function and the fan is rotating, showing that the drum is rotating. For some time, if you want to pass the program for a while for our need, so we have to press the switch 6. So as we see, the program is stopped. And to start the again, from that time, we have to press switch 5. As you see, the timer starts at that specific number only, which it doesn't came for that 1 minute. See, as we observed, as the washing program completed, the fan is stopped and the buzzer is ringing. So and a pop-up is appeared that our program was completed. And here also we implemented another thing that uh, if the door is not closed, a buzzer has to be ringed. So I will show you that. I will select these whites again. I will select the washing program again and again and start. Simply seconds. For the door is not closing option, we have to press switch one. As we, as we see, as switch one is pressed, a buzzer is ringing and a pop-up display is appeared that door has not closed. You have to close the door. This is a demo of the project, and we'll go to the presentation. Conclusion. The washing machine project using the PIC16F877A microcontroller demonstrates the practical application of embedded systems in home automation by integrating input devices like CLCD, switches, display keypad, and output interfaces. The microcontroller effectively controls the washing process through program logic and timing. This project showcases how the PIC16F877A can manage complex tasks like water control, drum rotation, and user interfaces, making it a cost-effective and efficient solution. Finally, through this online internship at MXC Technologies, we learned embedded systems and to write a code using CLCD switches, digital keypads, and operate them. So, thank you.